Hello everyone, welcome once again to another Python machine learning tutorial by Team Slidescope. In this part, we are building a house price prediction machine learning model using Python, and we will be creating a Ridge Regression model that you can see here. Using Ridge Regression model, we will try to predict mean absolute error, mean squared error, and R square score. I will try to explain you the meaning of all of this as well. Everything is explained here. I will provide you this code and keep explaining different methods, different classes that we are using here, and meaning of these errors and what is area of improvement here. This particular analysis or this particular machine learning model is created after understanding the data set. We created 3 dashboards on Power BI. We understood the data set, and based on our understanding, based on whatever we got from here, we are trying to apply that knowledge to create this machine learning model. So in this part, I will explain you all of this. Let's get started and build this simple model. So here you can see we are building a house price prediction model using Python, and it will be a machine learning model. But before this, you should go and watch our exploratory data analysis part. So here is a Power BI dashboard that we created. It has two parts where we try to understand real estate pricing and how it is affected by different features that are given in the dataset. Dataset is given here on this Kaggle URL. So you can see price, area, number of bedroom, number of bathrooms, number of stories, etc. are given here as well. So we can download this CSV file from here. We did exploratory analysis, tried to understand how price is getting affected, for example, house area versus price and so on. And now we will open Google Colab. We are using Google Colab. You can also use Jupyter Notebook or whatever Python IDE you want to use. Next thing is we will simply give it a headline. So I will copy this heading from here and I will just give it to my Colab notebook, and we will enter here also that we are doing this. And then you need to connect. So it will connect to Python backend, and then once it is connected, you have this folder here. So you can see it is written files. What you need to do is once the connection is made, you need to add that file to your session, to your current Google Colab session. So you can see it is connected, and now you can click here or you can upload this file. So there is an upload option. You can upload to session storage. Here you can see I have more than 200 files, but I will upload this housing file and click OK. Now it will give you a warning that ensure that your files are saved elsewhere, and this runtime will be deleted when runtime is terminated. So basically, if you are coming again and you want to reload this notebook, so you have to do this step once again. Now we will add a code cell here, and this is file. So this is, we can copy path, and now we can write this is file URL, and file URL will be this content / housing.csv. This is where this file is stored currently in this session. And once you will run this cell, now you at least have your file. Next thing will be to import the necessary libraries, like we need to import pandas for machine learning. From sklearn we need to import some different algorithms, so that I have already written here. So libraries that you need to install are pandas, numpy, seaborn, and matplotlib.pyplot as plt. So we will copy this, and we are importing all the necessary libraries. So these libraries are already installed in Google Colab. We don't need to install them. If you are seeing any error like this library is not found in your IDE, then you need to do this part, pip install, and then you need to install these libraries. Another library that we will need for machine learning purpose is from sklearn model selection. We will import train test split and cross validation score random site search. Then from sklearn pre-processing we will import standard scalar one hot encoder from sklearn and different. So when we will complete this code and when we will execute this code, I will explain you meaning of these libraries as well. So these libraries are for data processing. You can see these are for data processing and those type of purpose, and this is for machine learning. Seaborn is used for some exploratory analysis and data visualization as well. So we will import these libraries also. From here you can add another code cell. Next is we will load the data set. You saw that I already created the file URL which you have to replace with your CSV path. So you can do that easily. And what we need to do is we have to write this command and then we have to copy this. So what this is doing is we are using pandas library ed and we are reading CSV file where file URL is this CSV file that we have here. So that's what we are doing here, and loading, then we are printing the shape of this file and we are showing that df.head. df.head is basically it prints top 5 rows of the data. So when you will run this, you will be able to see shape of this file and head. So shape of this file is 545 point comma 13. That means that we have 545 rows and 13 columns, and then df.head is this. So you can see the columns and their price and their values. So you can see price, area, bedroom, bathroom, stories, etc. So this is important for you because then you will be able to see if values are properly there. Once it is done, you can do some quick exploratory analysis, although we did that, but now this part will be there. So for quick exploratory analysis, we will first copy this. So thing is, these are comments, these will not be executed. So first we will print data types. You can see there are multiple columns here. It's a data frame where we have price, area, bedroom. So some of them are numerical columns, some of them are categorical. So df.d types, this will give you all the data types and print missing values. So df dot is na dot sum, that means is not available or is not a number, like if it is a missing value, how many missing values are there in columns, and then basic statistics like count, mean, first quartile, second quartile can be seen with the help of describe method. So once you will do that, so here you can see these are the data types. Price as integer, area, bedroom, bathroom, stories, these are integer, and main road, guest room, basement, these are object, that means string values, alphanumerical values. How many missing values do we have? We don't have missing values in any column. Then here we have our describe. This particular data frame is the output of describe method. Price, area, bedrooms, bathrooms, stories, parking. So we have count. You can see in every case count is 545. This is simply 5.45 into 10 raised to the power of 2. Then we have mean value, standard deviation, minimum, first quartile, second quartile, third quartile, and maximum value. So we have values like this. Now we can convert typical yes no to binary. Why we are saying, for example, here in main road it is either yes or no, guest room is either yes or no, basement is either yes or no. So we need to do that. So, and as I said in our exploratory analysis part, so here you can see we have the dashboard that we created using Power BI, where you can see we have average price by hot watering guest room. So how many values of yes and no are there, and what are the average price of these houses by these different values. But in this case that we are building a machine learning model, we will change them to uh, you know yes no to binary if present. So convert typical yes no to binary if present. Some columns contain yes no. So binary columns are main road, guest room, basement, hot watering, air conditioning, and pref area. And what we are going to do is for C in binary columns, if C in df dot columns, that means for column in binary columns in this list, if C in df dot columns, if column is in df dot columns, dfc, that means we are checking from df, we are mapping yes to 1 and no to 0 as type integer. So this will run a loop and it will change our data frame structure. Now if we will write df dot head, so you will be able to see that now all those columns which were appearing as yes and no are now appearing as 0 and 1. Furnishing status still remains this, so we need to change it as well, because before applying these columns to machine learning, or before applying using these columns in machine learning models, we need to change them to these type of values. We need to change them to numbers, otherwise it will not work. Now comes furnishing. So like if furnishing is categorical with values like furnished, semi-furnished, unfurnished. So if furnishing is status in df dot columns, we will we are using it as type str. Obviously here at this moment you will see that it is not changed. We have just changed it to string or confirmed it as a string. Remove or cap obvious outliers if needed. So, so basically machine learning models cannot directly work with them, but we will see. For this we need label encoders. So this is something that we will deal with later. Now next part is we will remove or cap obvious outliers if needed, for example price or area. So df equal to df where df price is greater than 0 dot copy. So we are copying all the values where df is greater than 0. Remove rows where price is less than equal to 0. If there is anything like that, that will be removed. Then we will do some feature engineering. So for feature engineering, you can see here that we will create useful feature like price and price per square feet, maybe in interaction terms. If price is in df dot columns, like if this name is in columns and area is in columns, so if both of these are in columns, so price per square feet will be df price divided by area, and we will replace it with 0 np dot nan. So we are basically creating a measure that we created here, if you remember. So we created this, and here we created price per square feet, this. So price per square feet was created using simply by dividing total price by total area. So here we are using that, and price per square feet we are filling all na values if there are any na values with price per square feet median. So this, if we will write df head, so you will see that now we have a new column called price per square feet. And so it is basically we are dividing this by this, and we have created a calculated column here. So it's just equivalent of that. So let's say an example here. Here example total rooms would be bedrooms plus bathroom. So if bedroom in DF column and bathroom in DF column, so we can say that total number of rooms will be bedrooms plus bathrooms if you want to go with that. So this is another column that we can add, and you can have df dot head and calculated column will be created, which you can see here. So total rooms, price per square feet. So this is all being done to ease our calculations, although you can go with whatever you have, but here we have these values. Now drop we will drop those columns that are identifiers. So we don't have any column like id, so if it is there, so we will remove that. If you remember, here we created a column called index, which was working as an identifier for us. So this index column was created, but in our case we don't have that. So this index column was having unique id for each house, so we don't have that, so we don't need to drop. Then we will set features and target. Before using machine learning models, we create a target, that is price. So we are using x is equal to, x is our inputs. So we are just dropping columns which is target, which is price, and y will be all the values inside price column. So this will create all the columns that we have. This will create x and y. Then we will identify numeric and categorical columns. So we will identify numeric and categorical columns. Like numeric columns will be in X, we are selecting data types that include int 64 and float 64. So if you remember, in starting we use df.dtypes property to find out which columns are integer and float. So in our case, because we don't have float, so we can ignore this, but you can save it as a template that in some cases you will have that. So int 64 float 64 dot columns to list. So this will create all numerical columns. Then we are using categorical columns. If data types include object or category, we will put them. So here you can see earlier these data types were objects. Now we have changed our data frame, so we can write df dot dtypes, and here you can see we have integer because price per square feet is float, so that's why. And here you can see furnishing status is object. So all our categorical columns will go in this list, and numerical columns will go in this list, and we will print them. So here you can see numerical columns and categorical column. So whenever we are working with these type of data sets, it is always good to understand difference between categorical columns and numerical columns and how they are related. Next thing is we will use train test split. So for train test split, we will use x train x test, y train y test. We need to create these four variables, and then we use the train test split, where we use arguments as x and then comma y, and then we give test size, and then we give random state. You can select any random number here. This test size 0.2 means that we are going with 20% test size. So let's say there are 500 and 500 column 500 rows, sorry. So these 500 rows will have 80% of these 500 rows will go into training, and 20% will go as testing. Now we will print their shapes also, so that we can understand how many values do we have in xtrain and xtest. Note here is you have to remember this sequence, because this particular expression, the output of this particular expression will create 4 variables, so you need to remember. Xtrain is training input, xtest is all these are data frames. So xtrain is a data frame with training data, xtest is the data frame with testing data, ytrain is a series or a single column with training data of these values, and ytest is the, again it's a series where we have testing values of these inputs. And that's why we call it supervised machine learning, because we have some samples for training, and then on the same samples we are testing the model also. And when you will print their shape, you will see 436, 14. That means in training data frame we have 436 values and 14 columns, and in testing we have 109 values. So this is what, if you want to see what is there in ytrain, so you will see that it's a nd array. So we just need to run this. So you can see, if we will see an n dimensional array, it's a single dimensional array, just like a series. So that's what it gives. So earlier I mentioned them as data frames, but this time it is giving it as n dimensional array, because earlier when we, in earlier versions, most of the times these were given as data frames and series also. But in this case, these are n-dimensional arrays. So let's remove this. Now we are pre-processing pipelines. That is, we are using numeric transformer. So here in pre-processing pipelines, you can see numeric pipeline scale we are using. We are using numeric transformer. So we are using this pipeline where we are saying steps is equal to scalar, and then we are using a standard scalar. So let me explain this. First we will run this. So if you see here, we have the standard scalar, but what is meaning of this? So let's understand that. So basically our code creates a pipeline for numeric features. In short, this pipeline tells the model for all numerical columns scale them properly before training. So we are scaling. Now what is a standard scalar? The standard scalar transform each numerical column so that mean equal to 0, standard deviation equal to 1. This will help machine learning algorithms perform better, especially for linear regression and logistic regression, or KNN or SVM neural networks, etc. Why you should use pipeline? It keeps pre-processing organized. It ensures scaling happens only on numerical columns, and it avoids data leakage. It fits and transforms data automatically inside the model workflow. So for all numerical columns, scale them properly before training. So we did numerical scaling. Now we have categorical pipeline. We will use one hot. So in categorical transformer, here we have numerical transformer. We will again use pipeline as we did here. Here the step was a scalar. We wanted to do standard scaling. Here we are using one hot. We are using one hot encoder, and we will handle unknown and we will ignore. So here we have preprocessor, column transformer. We will use transformer equal to then num, that is numerical transformer, numerical columns. So again, there's a lot to understand here as well. So for categorical transformer, when we are using this pipeline is applied to all categorical columns. It converts each category into 0, 1 dummy columns. Example, furnished. 100. Handle unknown will be ignored. So that's what we have done. If new categories appear in test data, the model will ignore them instead of breaking. Sparse is equal to false, returns a dense array which is easier to work with. So this pipeline tells the model convert all category or categorical columns into one hot encoded numerical columns. Then we are using preprocessor. So here we are using column transfer. Applies different transformation to different set of columns. Num apply numerical transformer scaling to numerical columns. Cat apply categorical transformer to categorical columns. And remainder is equal to drop all other columns that are not listed. Why this is important? It keeps pre-processing clean, ensures correct transformer for each column type, and prevents mixing of numerical and categorical operations. And it can get integrated directly into ML model pipeline. So let's apply that. So here you can see we are getting an error. So let's fix that. So let's change this. By doing some research, we can see that uh, here is sparse output equal to false will be there, because in new scikit-learn they accept like this. So now you can see it is fixed. Then in the seventh step we have our baseline model pipeline, that is ridge regression. So here we have copied that. First we are creating this ridge pipeline, and then we are using fit as we used to do in linear regression. Then we are predicting. So I will explain you meaning also, and it is giving us some scores. So here is the complete explanation of this. So it starts from here. Explanation of the ridge regression pipeline. So this section builds baseline machine learning model using ridge regression inside a pipeline. A pipeline helps us combining pre-processing plus model training in one clean workflow. So first we will learn about creating the pipeline. So obviously as we created a pipeline earlier, so here we are creating a pipeline with steps as preprocessor and regressor, then ridge alpha 1 random state 42. So preprocessor applies scaling to numerical columns, applies one hot encoding to categorical columns, ensures the model receives clean numerical output, because machine learning model will not work with non-numerical inputs. Then we are using the regressor equal to ridge, a linear regression model with L2 regularization. This reduces overfitting. Alpha is equal to 1.0 controls regularization strength, and random state 42 ensures reproducibility. This pipeline ensures the exact same transformations used during training are applied during prediction. Then we train the model with ridge pipeline.fit. So we are fitting X train and Y train. Then the pipeline fits the preprocessor on training data, transform the training data, trains the ridge regression model, and then make predictions. Now we are doing predictions. So Y prediction ridge will be ridge pipeline dot predict test. So we are predicting on testing values, and this automatically applies pre-processing on the test set and then makes predictions. Then we are printing mean absolute error. Then this is ridge RMSE, root mean square error, and then R square score. So R2 is score. In mean absolute error, we apply Y test and Y prediction ridge. In this we use np numpy.sqrt square root of mean squared error, where we are applying arguments in the same order, and then r2 score. So all these different functions will give you these outputs, and here average error in the same unit will be there. More, and root mean square is more sensitive to large errors. How much variance in house price the model explains. 1 means perfect, 0 means useless model. If something falls in between, that it gives accuracy of the model. So R square is approximately 88%. RMSE is very high, and Ridge MA is also, you can see, 5,06,014. So what can we get from these values? So now we have model performance insights using Ridge regression. MAE approximately 5 lakhs. This means that on an average the model's house price prediction are this much off from actual price. For real estate datasets where prices often range from 50 lakhs to several crores, this is a reasonable and expected error margin. MAE gives a real world error understanding. Then RMSE is 7.69 lakhs. This penalizes large errors more heavily. A higher RMSE compared to MAE shows the model occasionally makes large mistakes for certain properties, and possibilities are luxury or extreme price outliers. R square, as I said, 0.883. This is a strong result. It means the model explains 88.3% of variation in house prices. Only 11.7% of price variations are unexplained. This indicates that the feature used like area, bedroom, bathrooms, amenities, etc. are highly predictive. And in real estate modeling, an R square value above zero point 0.8 is considered very good. Overall insights is our ridge regression model is performing quite well, showing high accuracy, reasonable error levels, stable predictions. But there is still room to improve, especially to reduce errors. We can try random forest regression, XBoost, performing hyperparameter tuning, remove extreme outliers, and apply log transformation on price. So that's what we have done in next steps. So you can see, so we have discussed up to step number 7 here. In next part we will discuss more steps. And you can also copy. I will give you the code. You can also apply random forest, XBoost. Then you can perform cross validation, hyperparameter tuning. Everything is given here, and I will explain it to you in next part. So in this part we have applied this, and you can write, and I will just write that in this part we are doing ridge regression or creating ridge regression model or pipeline. So in the next part we will come with more algorithms to try on this. Till then, try this. If you have any questions, please ask them in the comment section. If you have anything to add here, any suggestions, anything, you can put them in the comment section as well. Thanks for watching this part. Have a nice day.